The topic that we'll be going through now is an introduction to PLCs and also the introduction to one of the well-used standards around the world regarding programmable logic controllers, and that is IEC 61131-3. There are also local equivalents, but the main one is the IEC. My name is John Viparaitis. I'll be going through the session today. So what we'll go through is an introduction to PLCs, a brief history of the PLC, what is also available in process automation or industrial automation, and where did the PLCs fit in, why they've become so widely accepted, but also why there is issues that tend to be counterintuitive in this age, but also rely upon a very large population of maintenance people who have lingering doubts about the advent and also introduction of PLCs into their plant. So the actual word PLC is an acronym, which basically means Programmable Logic Controller. Now, it is actually a trademark of was a trademark of the Rockwell, the Allen Bradley Corporation, which then turned into the Rockwell Corporation. So, but the idea is it was, as originally intended, was to be a way to allow factories and process automation plants or process plants to be automated and remove the next step away from manual control into what is referred to as relay control. And relay control is then the single function hardwired logic that is then being replaced by a programmable logic, and hence the term programmable logic controller has come up. Now, it is was initially conceptualized by a requirement from some process engineers at the General Motors Corporation around about the late 60s, and they had a particular problem in that they needed to change their factory setup, in other words, their tooling setup, and it was driven by relay logic. And they found that the changeover times of the factory, in particular the control changeover times, were far exceeding the actual running times of the production. So it became clear that they needed to adopt a more flexible solution, a more adaptable solution at the shop level, and hence the PLC then became a reality. It was given generally by Modicon to take on that task. They produced a system that included a processor and a series of inputs and outputs that will then be able to change. But the idea is it was intended and functioned as a replacement for the relay logic. So what can it actually do now? Well, it can obviously perform relay switching tasks. It is able, through developments since that time, to be able to take in a lot larger range of functions, including calculations, counting, and also using process analog values. And an analog value is a signal that will come from a sensor which will be mimic the actual process. Okay, so it does also allow the flexibility to modify the control. is able to change the process very quickly, and typically in the terms of in simple changes in the fractions of seconds, in minor, major changes in the matter of days. So it is far more efficient than having to relay logic. It also allows troubleshooting to occur and gives you a very good interface into the allow an operator to interface into the machine. So there are other types of systems, including PC-based control system or personal computer-based control system, and also embedded controllers. And a lot of these actually take in some more the extension of the PLC, whereas the PLC typically is optimized for what is referred to as machine control, and tends to really look at the inputs and outputs of a machine and hence function in that way. When the requirement does become a little bit more than straight inputs and outputs, the idea of using a higher level type of mathematical computation is an overhead generally on most PLCs that affects its performance. So hence there is a trend, a need to go for more complex type of independent computing devices, and that's where the terminology including embedded controllers and PC-based controllers have come up to a fore. And they also allow a higher level of mathematics, including many of the computer-based programs or programming languages. They do a lot of interfaces into other systems as well, and the ability to take online data is also included in there. So as you may then understand, that the convergence of technology has become a major feature. So no longer is a PLC and also its associated equipment purely hardware-based relay logic replacement. It is a convergence of computing, HMI, and what could also be described as a SCADA and DCS system. So you will get a great deal of overlap at the moment. And the idea is that the technology, as it takes on more and more of the commercially available IT sector, becomes more akin to the larger aspects of, or the more complex aspects of production. So when we are trying to look at deciding on which PLC or embedded controller to use, we tend to look at the reaction time of the process and also the setup times of the actual controllers, including the PLCs. What type of application is able to be used? Do you need a dedicated controller to do time-critical issues, or can it be a more generalized controller? If you take a fairly small amount of PLCs for an application, you need to look at the ability of both the system and also the requirements of the plant or the customer. Okay. So one of the parts that are often being developed is a hybrid computer with a using of the PLC ruggedized hardware. Now, I mentioned earlier that PLCs were actually optimized for a hardware machine control, and hence they had the mechanical and electrical interfaces that will be suitable for that, whereas a computer doesn't have that, and is designed, the computer is mainly designed for commercial applications. So a hybrid of that, referred to as a programmable automation controller, does have physical hardware devices which are typical of a PLC. So in other words, it does have the inputs and outputs and the terminals and the interface isolation units that do have it. However, it instead of having a embedded cyclic processor, it uses a more generic parallel processor, or a group of parallel processors, such as what you would see in a normal computing. So the interface and the logic are a hybrid. What is the most important aspect to these type of things is networking. In other words, the networking of the PLC hybrid as an entity becomes an important thing, because it interfaces to not only the machine itself, it also interfaces to all the other networked systems, including the commercial systems, the any type of production equipment, is a factory coordination. The idea is that the networking part becomes an important aspect. So in summary, the PAC, or the Programmable Automation Controller, has a PLC field. In other words, its footprint, its ability to take input-output, but it has a large memory compared to a normal PLC, a high-level data handling capabilities, and a very large communications or networking capabilities. Now, again, this is one of the byproducts of the effect that I mentioned earlier about the convergence of technologies. So, and a lot of the manufacturers of conventional PLCs have also increased their own products capabilities to reflect this as well. So the PLCs tend to have proprietary programming, whereas the PAC tends to have open programming, basically going for the computing type of languages. All the systems and the programming tend to be based around relay logic or relay circuitry, whereas the other one tends to have a far greater flexibility and tends to have, instead of having continuous scanning, it has distributed processing. And in the way, one of the fundamental ways that the differences are also being distinguished almost arbitrarily is the way that the system handles its inputs and outputs, and hence the PLCs tend to be hardware addressed. In other words, where you physically place the cable onto the frame is where you will actually get the data, whereas the PAC and some of the more complex PC-based systems use a variable tag as its addressing mode, and it doesn't necessarily have to be in the tied to the hardware, but the configuration just as you would a normal computer network sets that. Okay, so what makes the PLCs so attractive and very ubiquitous in industry, and more than just industry, in many different places where the need to have a consistent action of a machine, it becomes important, because they are cost effective, they are very reliable, they are flexible, reliable, and compact. That's the main thing, is that they are ruggedized and also suitable for the interface as well as their architecture. They are flexible. They allow a great deal of visibility into their systems, and hence make troubleshooting a lot easier and reduce downtime. So they are basically used in many different, and in fact every industry that is required to have as I said, a consistent operation of machine, and hence automation is involved. And they do encompass every industrial process that is available at the moment. So so what do the actual PLCs do to the process is that they produce the logic, and hence the outcome of things like sequencing, batch processing, counting, interlocking, timing, and also safety controlling. So it is there to make sure that the sequencing of a particular machine is kept within the bounds of the normal operation. In addition, they also perform the ability to talk to and communicate to other devices and other devices in the network. So what do they look like? Is basically this is a small PLC, and there are many different larger types, but they basically start off with what could be referred to as a shoebox PLC, in that the processor, the input and output interface are all on the one plane. It also has the communications as well. So now this is considered a small PLC, fixed inputs and outputs ratio, and also fixed input and output maximum number. The next development, which is really where PLCs started, is what is referred to as a modular system or a rack-mounted system, where you are able to slot in various hardware components into the backplane of the PLC. That's the hardware,